Thank you for my introduction, Ito Sensei. My name is Masaru Ochiai from Kitasato University. I'm very grateful for the opportunity to talk in this forum. My presentation is about the potential of edible insects as alternative novel food and feed resources. There are 5 topics in this presentation. First, fine insect for food and feed. Second, edible insect recognized as food and feed in the world. Third, safety and nutrients of some edible insect powders. Fourth, nutritional and physiological function of edible insects. Finally, future perspectives and important issues. At first, fine insects for food and feed. Increase world population, increasing imported prices of livestock feed, and global warming can induce animal food protein crisis. Recently, alternative protein materials are increasingly focused on. This picture shows books and magazines regarding the alternative food materials in Japan, and shows alternative food and beverage department in Italian and USA markets. So there are increasing concern about the alternative food resources for the non-research population as well as research population. Edible insects are also increasing the focus on alternative food and feed resources. In 2013, FAO published a book entitled The Edible Insects, Future Perspectives for Food and Feed Security. This is the start of edible insect research. In 2018, some insects were officially recognized as novel foods in European Union. So recently, edible insects has been focused on as food tech. PubMed literature search shows about 1,200 publications in the present and are increasing. This slide shows the advantages for the utilization of insects for food and feed. There are 3 points. First, nutrients rich in protein, lipids, and dietary fiber and minerals. Second, food efficiency, feeding cost, feeding period, land, and edible parts is very well. Third, greenhouse gas emissions are very suppressed. Next is edible insect recognized as food in the world. The EFSA, European Food Safety Authority, provides impartial information on the risk assessment of food and feed. According to the EFSA report, more than 2,100 species of insects are officially recognized as edible with safe. But the number is very limited to the larval stage of yellow mealworm, lesser mealworm, and adult stage of migratory locust and house crickets. Some publications by the EFSA reports EFSA reported about the frozen and dried powder from house crickets, yellow mealworm, lesser mealworm, and migratory locust, and UV treated for yellow mealworms. Next is safety and nutrients of some edible insect powders. Our presentation is about the migratory locust. A previous report about the safety of edible migratory locust powder sold in Japanese market was published in 2020, and the detailed information were referred by the EFSA journal in 2021. This review has recognized the commercial minority low-cost powder as safe. This slide shows the micronutrients of some edible insects. Locust, silkworms, 3 kinds of crickets. In particular, edible locust contains a well-balanced protein, lipids, and others. The silkworm and 3 kinds of crickets contains lipids more than locust. In this presentation, characteristics of protein and lipid will be presented. Dietary protein values are in general evaluated by the protein and the amino acid abundance, amino acid score, and amino acid profile and score, gut-intestinal digestibility, and bioavailability. However, in case of insect proteins, there are some important issues regarding the presence of non-protein nitrogen, essential amino acid abundance, and resistance to digestibility. We have recently pointed out this information in these publications. This slide shows the essential amino acid profile and the scores of edible insect powders. Limiting amino acid of locust are tryptophan, methionine, and lysine. And amino acid score 63 for locust and 94 for silkworms, and 84 to 87 for 3 kinds of crickets. In evaluating the protein abundance of edible insects, some problems regarding the Kjeldahl method are observed. In general, by using the Kjeldahl method, the total nitrogen content could be determined, and then total nitrogen content is multiplied with the nitrogen to protein conversion factor value of 6.25. In case of insects are categorized as non-food or other food materials, so the conventional NPF value of 6.25 is used for the protein quantification. However, insect contains nitrogen contain dietary fiber, chitin, in some extent in the exoskeletal body. And so chitin nitrogen can affect the net protein content. According to our result, chitin-derived nitrogen is contained in the total nitrogen. So chitin content was calculated from 1.6 to 10.7%. In particular, locust contains about 10% chitin contents in the powder. A large difference, about 12.5% in case of migratory locusts, are shown between the crude protein and true protein contents. And the gut-intestinal digestibility is important because edible protein are resistant to gut peptide digestibility. Tropomyosin, like proteins known as food origin compounds, cannot be degraded by peptide peptide in vitro and gut in vivo in my previous works. And the gut-intestinal digestibility of edible insects are 70, 86, 83, 82, and 77%, which are the KCM of 97%, which suppress the PDCAS. The PDCAS protein digestibility correlated amino acid score, which are calculated by multiplying amino acid score by gut intestinal digestibility, 44, 81, 44, 81, 65 to 72 for locust, silkworms, and 3 kinds of crickets. The lipid quality are also evaluated by their quality and quantity. The tested 5 kinds of insect powder have well-balanced fatty acid composition. In particular, polyunsaturated fatty acids are contained in compared to the conventional livestock materials. The amount of lipids in locust are small, as reported before, but the omega-3 fatty acid, particularly alpha-linolenic acid, are dominant in the PUFA content. Silkworm lipid is similar with the migrated locust lipids, but is different from the 3 kinds of cricket lipids. In addition, these PUFA are not always binding to triglyceride form in these insect powders. This TLC figure shows the lipid species collativity, such as triglycerides, neutral lipids, phospholipids, and fatty acids. The locust contains the PUFA as phospholipid forms as well as triglyceride forms. The next is the nutritional and physiological function of the relative insect, limited to migratory locust. As described before, locust contains a lipid and dietary fiber kitchen as well as protein. Phospholipids and omega-3 linoleic acid are rich in the lipids. These lipids and dietary fiber kitchen can improve the lipid metabolism. So to investigate the possibility, we firstly examine the effect of locust powder on lipid metabolism in normal Western rats. Rats were fed a controlled diet, or 10% locust contains a diet for 5 weeks. Plasma biochemical compounds, plasma lipoprotein and fatty acid composition, liver lipid content, and lipogenesis related enzymatic activity in the liver were measured. This table shows the result of plasma biochemical compounds, components. Plasma triglyceride and total cholesterol levels were largely suppressed by the locust. So next, the lipoprotein was separated to 2 kilomicrons, 5 VLDL, 6 LDL, and 7 HDL subfractions, and quantified by the Gale-filtered HPLC method. This slide shows the result of plasma level of each lipoprotein fraction. Among the 4 lipoprotein fractions LDL, particularly very small LDL fraction levels were very lower in the locust groups. The very small LDL levels are closely associated with atherosclerosis and lipid metabolic disorders. This slide shows the plasma fatty acid composition. The locust diet increases the omega-3 fatty acid composition, such as linoleic acid, EPA, and DPA. So The locus improves the omega-6 per omega-3 ratio and atherosclerosis indirect index, such as C25, 24, increase the alpha-linolenic acid, and EPA can prevent the omega-6 lipid-induced inflammation and lipid metabolic disorders. This slide shows the result of the effect of locust on liver lipid content and lipogenesis markers. Liver triglyceride content was increased, but on the contrary, lipogenesis markers of SREBP1 protein expression and their related enzymatic activity, such as GLPDH, FAS, FS, and ME, were also suppressed. This slide shows the discussion about the possible mechanism for the improvement lipid metabolism by the locust. Locust is expected to improve the lipid metabolism in normal rats through the lipoprotein metabolism. Decrease in the LDL and very small LDL fraction are expected to the upregulation of the LDL receptor. So we focus on the PCSK9 levels in plasma. LDL receptor is degraded and suppressed by the PCSK9. As this figure shows, the PCSK9 levels was half suppressed by the locust. Therefore, increase the lipid uptake into the liver can induce a high triglyceride content in the locust group. Also, no changed plasma VLDL content and suppression of lipogenesis in the liver are expected to suppress the VLDL production. So totally, plasma liver lipoprotein metabolism is improved by the locust. The regulation of the lipoprotein mechanisms and key chemical compounds are investigated in progress. Although the data is in progress, we are trying to search for functional compounds in the lipids. As shown in the lipid composition data from the lipid mix analysis, the presence of many species of lipid forms, and that alpha-linoleic acid is dominant fatty acid binding to lipids. Particularly, it is characteristic to contain the phingolipids and cholesterol and phytosterol lipids in locus, I think. Future perspectives and important issues about HIV effects. According to the market perspectives data in 2022, insect food markets are going to be expanded and can achieve the many SDGs and protect food security in the world. And also, the number of publications regarding the nutrients, safety, function, production and processing of insects and food and feed, and raising insect method for food and feed is expected to be increasing. This slide shows the insect food in the world. In case of Japan, people in Nagano prefecture have the insect food culture, but for other many people, there is a averseness to eating insect. So high processing is necessary, such as bread, cakes, biscuit, like something like that in Japanese markets. In case of Thailand, as you can see this picture, simply cooked, such as fried, deep heated, were prepared as well as chicken and shrimp in street markets for human food. In case of European countries, the approach for insect food is different among countries. This figure shows the authorized or not approved for insect as novel food in 2021. Color in green, yellow, and purple show the authorized On the contrary, color in orange shows that not approved. For example, Italian Food Association has not authorized insect to contain the insect to traditional food such as pizza and pasta because of the preservation of Italian food culture. This slide shows some important issues for the development of insect food and feed in Japan. First, averseness to eating insects. Second, safety and function. Third, recognized and authorized as novel food in Japan. Fourth, raising insect and manufacturing processing insect food and feed for sustainability. 5. Labeling of insects such as protein and kitchen for food and feed markets. And finally, education on the use of insects as food and feed for population is necessary. A review article in 2019 about the meat alternatives has also shown a higher demand for social institutional and technological changes to insect food and feed in compared to other alternative materials, such as plant-based meat and beans. And finally, summary and conclusions. Edible insect shows the nutritional abundance. In particular, locusts contain the alpha-linoleic acid as phospholipid and triglyceride forms. Protein amount are well, but the essential amino acid balance is not good. Dietary fiber kitchen contains at 10% in insect powder, which can affect the protein process quantification. Locusts show the nutritional and physiological functions such as lowering LDL lipid levels in plasma and suppressing lipid absorption and liver lipid synthesis. On the other hand, some important issues for the development of insects for food and feed in the future. This is the acknowledgement. Thank you very much for your kind attention.